This is the pre-lab video for our split range control lab here at Red Deer College. In front of us we have the process control trainer that we use for our split range control lab. I'm going to take you guys over to the workstation. I've already logged in and I have the screens for the process control trainer in front of us. I wanted to identify three control loops that you're going to be working with. Up here we have a pressure control loop, PIC 602. This control loop regulates the pressure in T603. This is where we're going to be controlling level with the split range control strategy. So we want to make sure that we maintain a constant pressure. You can see we measure pressure here, and then we control a valve here that we vent pressure off. We're controlling a back pressure in this vessel with this control loop. Our level control loop, LIC 602 is the controller, and it uses selective control. It can select between these two transmitters. It takes the higher of the two values and then sends it to our controller here. It has two signals leaving, one going to LCV 601A and 601B. These are our two valves connected in split range. So this is our level control loop. It has the split range control on it. And then the other loop that you're going to be working with over here is a flow FIC 601. It controls our pump P601 and it measures the flow with FT601 and controls the flow. So we're going to be pumping fluid out of this vessel up, over, and into T603 and then draining it back into T601 and using this level control loop to control this split ranged level control loop to control the level. And then up here we have the pressure control loop that's maintaining a constant pressure in this T603. The reason why we're maintaining that constant pressure in T603 is it makes the control loop work a lot better. If we have a pressure in the vessel, the water will drain a lot faster out of the vessel and the loop will act a lot faster. If we did not have that vessel pressurized, it would be a lot slower process. So let's go back over to the trainer and identify all the valves and transmitters for these loops. Our pressure control loop here, we can see here's our valve. We've got this little baffle to kind of dampen the sound as the air vents off T603. So this is the valve for the pressure control loop. So that was, we have PCV 602 and then we have PT 602 right here measuring the pressure. So this is the pressure control loop, and then the delta V controller acts as our controller. So there's not a standalone controller. We don't see the physical controller. It's in our delta V control system. Here's T603 right here. The vessel is going to be pressurized and the one we're controlling level in. Here's our two valves down here that are split ranged, and we have either our Drexel-Brook capacitance probe measuring the level, or a differential pressure transmitter LT603 measuring. So those two are hooked in selective to take the higher of the two values for that control loop. And then down here is P601. It's going to be pumping the fluid out of T601. It's going to go up, over, and flow through FT601. We're going to use to measure the flow. It flows back around over and comes over to this three-way valve. Here we can switch and have the liquid flow into T602 or over into the one that we want, T603, and it flows up, over, and into the top of the vessel here. So this video is made to help familiarize you with the process. We compared the HMI screens on the delta V control system to the actual process. There will be some pre-lab questions to answer based on this video.